Hey there, tech enthusiasts. Welcome back to another exciting episode where we unravel the mysteries of the electronic world. Today, we're diving into the fascinating world of capacitors. These tiny but mighty components are essential in almost every electronic device you can think of. These little components are the unsung heroes of modern electronics, quietly doing their job to make sure everything runs smoothly. They're found in almost every gadget we use, from our smartphones and tablets to our laptops and even our smartwatches. But don't let their small size fool you. They play a huge role. Without capacitors, our modern electronic world would come to a standstill. Our story starts way back in 1745 with a device called the Leyden jar. This was one of the earliest forms of a capacitor. Peter van Musschenbroek gets credit for the Leyden jar, a groundbreaking invention at the time, but Ewald Georg von Kleist made one around the same time. Both of these scientists contributed significantly to our understanding of electricity. Think of it as an early capacitor, a primitive yet ingenious way to store electrical energy. It was a glass jar wrapped in metal foil, able to store static electricity. This simple design laid the foundation for future advancements. This accidental invention sparked a revolution in our understanding of electricity, leading to more sophisticated designs and applications. It paved the way for the capacitors we know and love today, which are crucial in everything from power supplies to signal processing. So buckle up as we explore what makes capacitors tick, how they store and release energy, and the incredible impact they have on our daily lives. Stay tuned, because you won't want to miss this electrifying journey. Imagine a water tank. It's a simple yet effective way to store water for later use. You can fill it up with water, storing it safely until you need it. When the time comes, you can release the water to use it for various purposes, like watering plants or washing your car. That's kind of how a capacitor works. But instead of storing water, it stores electrical energy. Think of a capacitor as two metal plates separated by a non-conducting material called a dielectric. This setup allows it to store energy efficiently. When you apply a voltage across these plates, something cool happens. The plates start to accumulate charges. The positive plate starts accumulating positive charges, while the negative plate gathers negative charges. This separation of charges creates an electric field between the plates, which is crucial for storing energy. This electric field acts like an invisible force field, holding the energy in place. The stronger the electric field, the more energy the capacitor can store. And guess what? This field is where the electrical energy is stored, just like water in our tank. When you need the stored energy, you can release it from the capacitor, similar to how you would release water from a tank. So, the next time you see a water tank, remember that capacitors work in a very similar way. Pretty neat, huh? Now, let's talk about how we measure a capacitor's ability to store energy. We use a unit called the farad, named after the brilliant Michael Faraday, a pioneer in electromagnetism. 1 farad is a huge amount of capacitance. In reality, most capacitors you'll encounter have much smaller values, like microfarads, UF, or picofarads, PF. Think of it like this. A 1 farad capacitor could power a small city for a brief moment. That's a lot of juice packed into a tiny component. Section 4. How capacitors work. Storing energy in an electric field. In this section, we'll dive deep into the fascinating world of capacitors and how they store energy in an electric field. Remember that electric field we talked about? It's a fundamental concept in understanding capacitors. That's the key to a capacitor's magic. It's not just a simple component, it's a marvel of electrical engineering. When you apply a voltage, the capacitor charges up, building that electric field. This process is crucial for its operation. The dielectric material between the plates prevents the charges from jumping across, acting like a barrier. This material is essential for maintaining the integrity of the electric field. Now, when you disconnect the voltage source, the capacitor holds onto that stored energy. It's like having a reservoir of electrical energy at your disposal. It's like a charged battery, ready to release its energy when needed. However, unlike batteries, capacitors can release their energy much more quickly. This ability to store and release electrical energy rapidly makes capacitors incredibly versatile. They can charge and discharge in a fraction of a second. They can smooth out voltage fluctuations, filter signals, and even help start motors. Capacitors are used in a wide range of applications, making them indispensable in modern electronics. technology. Section 6. Capacitors. Tiny components, huge impact. From their humble beginnings as the Leyden jar to their ubiquitous presence in modern electronics, capacitors have come a long way. These tiny components, often overlooked, play a vital role in shaping our technological world. Next time you power up your smartphone or marvel at the latest technological innovation, take a moment to appreciate the unsung heroes working behind the scenes capacitors. They are a testament to human ingenuity and our relentless pursuit of harnessing the power of electricity. Remember, science rules,